press the bell icon on the YouTube app and never miss another update.
Hello dear students, now let me continue part 4 from system of particles and rotational motion. Okay, in that one topic is center of mass. So this is the fourth lecture of center of mass. See, in this lecture let me cover some basic problems based on previous formulas that what I covered in the last class. Anyhow, in the last class I covered coordinates in plane, coordinates in 3 dimensions and coordinates in vector form. We got RCM bar, VCM bar, acceleration of center of mass. Okay. Now based on those formulas, let me continue some basic level of problems to get some confidence. Okay, because next some beautiful concepts will come. Okay. Now here, anyhow, you know characteristics of center of mass. Just let me recall in a minute. So at the position of center of mass, mass may present or may not present at the position of center of mass, and in the absence of external forces, acceleration of center of mass is 0, but velocity of center of mass remains constant. And center of mass generally depends on mass distribution and their orientation, means position of the particles. Okay, center of mass depends on mass distribution and position of their particles. And generally we use Newton laws to study the motion of center of mass. So this is also the one of the characteristic of center of mass. So we can study the motion of center of mass by using Newton laws of motion. See, in the last class I used FCM bar. FCM bar nothing but m into ACM bar, that is nothing but Newton's second law of motion. Okay, and internal forces does not affect the position of center of mass. All are covered in the last class. Now let us start some simple problems to get some confidence or solving problems in center of mass from NCERT and any other textbook. Easy level of questions I am going to start. Okay. See, they given like this: if 2 kg mass shift by 4 centimeter right, 4 centimeter right, then at what distance, 6 kg mass to be shifted. Okay, at what distance 6 kg mass to move so that center of mass of the system remains constant. See, I given some general things, general problems I am giving now. Okay, so use this knowledge to solve problems from any other textbook. See, I given like this: 2 kg and 6 kg given. Indirectly 2 kg 6 kg are separated by some distance. 2 kg 6 kg are separated by some distance, they are not mentioned. Okay, so 2 kg 6 kg masses are separated by some distance. Okay, so that they will have some center of mass. If we know the distance between them, we can find center of mass from 2 kg by using m2d by m1 plus m2. And if they ask you to find center of mass from 6 kg, again by using formula we can get the answer. Here they are not mentioned the separation, just they are separated. 2 kg mass, 6 kg mass separated by some gap. 2 kg mass, 6 kg mass separated by some distance. Okay, they are apart. If 2 kg shift by right, how much? If this will be shifted by 4 centimeter right side. Okay, if we know the gap between them, we can find where the center of mass is located. Right now the distance between 2 kg 6 kg are not given. Okay, no need to worry. If 2 kg shift right by some 4 centimeter, then at what distance you have to move this 6 kg? Okay, at what distance we have to move this 6 kg so that center of mass remains at the same position. Center of mass remains at the same position means center of mass is 0. There is no change in center of mass. Okay, now we have to move 6 kg mass, whether it is right side or left side. Okay, so this is problem based on shift in center of mass. Okay, starting, let us take the origin. This is origin 0 comma 0. Next coordinates are, this is 0, this is 4 centimeter and 0. We don't know of this one. Okay, so to find this type of questions, you can use the coordinates method like XEM, like XEM nothing but m1 x1 plus m2 x2 by m1 plus m2. And in the next situation, when it moves, you will get some XCM dash, the new center of mass, XCM dash. Starting is XCM, m1 x1 plus m2 x2 by m1 plus m2. Once it moves, then the coordinates are changing. So m1 x1 dash plus m2 x2 dash by m1 plus m2, that is XCM dash. If you take the gap XCM and XCM dash, you will get the shift. Okay, so instead of finding all these things, anyhow you know the basic formula. The basic formula is XCM m1 x1 plus m2 x2 by m1 plus m2. Okay, generally we use this formula when these two are fixed. Right now these are changing, so you can use XCM dash, the next position, m1 x1 dash, m2 x2 dash by m1 plus m2. Take the difference between those two equations, you will get the given answer. Instead of that, just you apply some differentiation, some change, some shift you take. This XCM, let me write directly, delta XCM, directly, delta XCM. This m1, there is a change in x1. So m1 delta x1, this is nothing but shift in center of mass. There is no shift, nothing but 0. m1 delta x1, m2 delta x2 by m1 plus m2. So use this formula to solve this type of problems. It's easier way. So shift in center of mass delta XCM, which is equivalent to m1 delta x1 plus m2 delta x2 by m1 plus m2. Now what is the delta XCM? There is no, see, so that center of mass remains same, means there is no shift in center of mass. So this is going to be 0. So left side is 0. Shift in center of mass is 0 according to the problem. 2 kg, 6 kg are separated by some gap. If 2 kg moves 4 centimeter right, then at what distance you have to move the 6 kg so that center of mass remains constant. Center of mass remains constant means there is no shift in center of mass. So I am writing 0. There is no shift in center of mass means 0. m1. So let us take this is m1 and this is m2. Okay, m1 is 2 and delta x1. Delta x1. So the change in position of m1 is what? Starting is 0, ending is 4. So the change in position is 4 minus 0, nothing but 4 centimeter. Okay. Okay, if it moves right, you can take positive. If it moves left, you can take negative. That is the simple way. So anyhow, this is moving right. So 4. Delta x1 is 4. 4 minus 0, nothing but 4. Plus m2, 6. We don't know at what distance it is moving. Delta x2. Delta x2 is our target. m1 plus m2. 2 plus 6. 2 plus 6, this is 8. 8 into 0, 0. So 0 is equals to 8 plus 6 delta x2. So delta x2 is equals to minus 8. Okay, 4 and 3. So delta x2 is equals to minus 3 centimeter. That means what? Delta x2 is equals to minus 3 centimeter means 6 kg is moved left by 3 centimeter. If you move this 6 kg mass left by 3 centimeter, then center of mass of this system remains same. Okay. So if this 6 kg moves, see I got negative. Negative means what? Left side. If you got positive, right side. Positive right side, negative left side. So if this 6 kg mass moves left by 3 centimeter, then center of mass of this system remains same. There is no change in center of mass. Okay, so easy level of question. Okay, just for getting some confidence levels, increase some confidence level, I am doing these problems now. See, so how much you have to move the 6 kg? 6 kg move left by 3 centimeter. Then center of mass of this system remains constant. Like this, I will give you one more problem to get some confidence. Okay. Okay, let me give one more question. You try to do the next problem. Okay, problems models are so many. Okay, you try this problem. If something 4 kg shifts left by 4 centimeter, okay, then at what distance 8 kg mass to move, at what distance 8 kg mass to move so that the center of mass shifts right by 1 centimeter. See, the given center of mass shifts right by 1 centimeter. So try this one. I given some general questions. If 4 kg shifts left by, see, this is 4 kg. This is shifting left by how much now? I given 4 centimeter. Okay, whatever may be the numbers. Here according to this I have written numbers. And then what distance 8 kg to be moved? 8 kg mass to move so that center of mass shift right by 1 centimeter. So initially again 8 kg also separated by some distance. Now center of mass, initial center of mass is somewhere here, and it is shifted. This is initial center of mass, later it will be shifted by 1 centimeter. In a previous problem, center of mass remains same, means center of mass, shift in center of mass remains same in a given in previous problem, that I taken as a 0. Here center of mass is moves right, right means +1, if it is left -1. So use the same formula. So delta XEM they given in this problem, center of mass shifts right by 1 centimeter, right by 1 centimeter means it is 1, this is 1, it moves right by 1. If they given it moves left by 1, -1. M1, take this as M1, 4 kg M1. Okay, I am writing outline data. Okay, use this knowledge to solve some other questions. So this is M1, M2. Now M1 is 4 kg and 4 kg shifted left by 4, left, so -4, plus M2 8, and target is to find at what distance M2 should be moved by M1 plus M2, 4 plus 8. So this is a 12, 16, 8 delta x2. Okay, 12 plus 16, 8 delta x2. So this is 8, 28, 8 delta x2, 16, so 28. So delta x2 is equals to 28 by 8. Okay, so you can cancel it. 4 2s are 4 7s are. So I got positive. So 3.5 centimeter. So I got positive means what? Positive means 8 kg must be moved by right by 3.5 centimeter, so that center of mass will shift by 1 centimeter towards right. Okay, so 3.5, 4 this is 2s are 4 7s are. Okay, 3.5 centimeter. So 8 kg should be moved by, at what distance 8 kg has to move? So 8 kg must be moved by 3.5 centimeter right side, so that center of mass will shift by 1 centimeter right side. Okay. Yeah. Okay, let me give one more easy question from NCERT. Same models are there in NCERT. See, almost in this session I am going to cover very basic level of questions. Next session maybe the level may increase. Okay. So write the next problem. Three particles of masses 1 kg, 2 kg, 3 kg as shown. Then find center of mass of the system. So three particles of masses 1 kg, 2 kg, 3 kg as shown. See, they given the diagram like this. So indirectly they given like this. So okay, they given data, but I written in a shortcut way. See, three particles whose masses are 1 kg, 2 kg, 3 kg. They given 1 kg at here, 2 kg at here, 3 kg. So 1 kg, 2 kg, 3 kg are placed at the corners of an equilateral triangle whose side they given this is something 1 meter. Okay, let us suppose A meter, side is A. So three particles of masses 1 kg, 2 kg, 3 kg are placed at three corners of an equilateral triangle of side A. Nothing but maybe 1 meter, maybe 2 meter or 3 meter, whatever. Okay, so side is A. Now we need to find center of mass of this system. Okay, here they given this is origin, they given this one. So this is x axis, this is y axis. Now we need to find xcm and ycm. Okay, xcm and ycm. Two coordinates, because it is a plane, xy plane. So we will get two coordinates. Here let us take m1 as 1 kg, m2 as 2 kg, This is M3. Identify 3 particles and identify coordinates of 3 particles. Once you know the coordinates, we can get directly by XCM and YCM. So, what are the coordinates at this origin? Okay, let us take this is some ABC or OAB, whatever may be the name. Here the coordinates are 0, 0, 0 and 0. Coordinates at here is 0, 0. Here coordinates, if it is a 1 meter, 1, 0, but they given A, comma 0, A, comma 0. Here at this one, this is a 3 kg is in XY plane, 3 kg is in XY plane. So, from here to here is A by 2, A by 2. So, x coordinate is A by 2. And this height, use the Pythagoras theorem, this height, or use some triangle system. So, this is an equilateral triangle, so this is how much now? 60 degrees. Okay, directly we can write root 3 A by 2, okay. Okay, let me get it for some students especially. So, 60 degrees, and this is what? This base is A by 2, this something height H, okay. Opposite side, adjacent side, use tan 60. So, what is tan 60 here? Let me write here roughly. Tan 60, is it visible downside? Tan 60, yeah, tan 60, see this is A comma 0. I think most of the students know these coordinates. Tan 60, which is equivalent to H by A by 2. So, H is equals to A by 2, tan 60 root 3. So, root 3 A by 2, root 3 A by 2, okay. So, what are the coordinates here? Root 3 A by 2. Use Pythagoras theorem, otherwise this is an equilateral triangle, so you can use tan 60. So, 60 degrees, 60 degrees, 60 degrees, and height we need to find. This height nothing but y coordinate. So, y axis by x axis nothing but tan theta slope, okay. So, tan 60 H by A by 2, so you will get root 3 A by 2. I think you know this one, let me write, okay. So, anyhow I got 3 particles of masses M1, M2, M3 and coordinates also I got it. Let me write the data. M1 is what? 1 kg, X1 0, Y1 0, M2 2 kg, X2 is what? A, Y2 0. Directly we can write 3 kg, X3 A by 2, Y3 root 3 A by 2. So, I got 3 particles and I got 3 coordinates of 3 particles, okay, coordinates I got it. Now, the target is to find out XCM, YCM. So, anyhow we know the formula XCM. So, let me write the formula once. M1 X1 plus M2 X2 plus M3 X3 by M1 plus M2 plus M3, okay, M1 plus M2 plus M3. Now, XCM, M1 is 1 kg, X1 0, you substitute all these things, okay, M2 2 kg, X2 A, M3 3 kg, X3 A by 2 by M1 plus M2 plus M3, 1 plus 2 plus 3, 6, okay. So, this is 2, 4, okay. So, 0 and 2A, 3A by 2, so 4 plus 3, 7 A by 12. This is x coordinate of center of mass. So, basic level of question. So, 7a by 12. Similarly, you try for YCM. If A is given as a 1 meter, 7 by 12. So, try YCM in the same manner. Use M1Y1 plus M2Y2 plus so on MNYN by M1 plus M2 plus M3. Okay, for n particles that is. Okay, try YCM coordinate. I got XCM coordinate now. Now let me write YCM coordinate. So you write the formula, YCM formula. I am writing directly now. M1Y1 plus M2Y2 plus M3Y3 by M1 plus M2 plus M3. M1Y1 1 into Y1 0, M2Y2 2 into 0, M3Y3 3 into root 3 A by 2 by 6, 1 plus 2 plus 3, 6. So, this is 3 root 3 A by 12, 2, 6, 12, 4. So, we got root 3 A by 4. Root 3 A by 4 is the y coordinate. Now, we got XCM, YCM values are XCM and YCM, which is equivalent to 7A by 12 and one more is root 3A by 4. 7A by 12 and root 3A by 4. Okay, if they ask you to find distance of center of mass of the system from origin, you can use the formula. If they ask you to find distance of center of mass of the system from origin, if they ask, you can use XCM square and YCM square. So, 7A by 12 whole square, root 3A by 4 whole square, you will get some number. Okay. Yeah, see one more question. So, let us find this. Find center of mass of the system as shown. Find center of mass of the system as shown. Center of mass of the system as shown. Let us see what type of system they given. Okay, in a problem they will give the data clearly, but here I am going to explain the data. Here they given. Okay, let me draw the diagram. From the diagram we can expect what they given. See, they given like this. Okay, all are identical. So, this side let us suppose 1 meter. 1 meter. Okay, this for meter, this for mass. See what they given is 4 identical particles. See, all are mass m m m m. 4 identical particles are placed at the 4 corners of a square. 4 identical particles of each of mass is m are placed at the 4 corners of a square of side 1 meter. 4 identical particles each of mass m are placed at 4 corners of a square of side 1 meter. Then find position of center of mass of the system, okay, or coordinates of center of mass of the system. Position or coordinate. Yeah, this is m m m m, side is 1 meter, and here this is the origin. What are the coordinates here? 0 0, and here along x axis this is 1 meter, so 1 comma 0. Here this is along y axis. I think you know these basics in your basic mathematical knowledge. So anyhow I am explaining everything. So here the coordinates are 0 1, here the coordinates are 1 1. It is in xy plane 1 comma 1. So take this is m1 m2, okay, m1 m2, anyone is m3, anyone is m4, but all are same. m1 is m, what is x1? x1 is 0, y1 also 0. So write along with me, m2 also m, x2 is 1, y2 is 0, m3 is also m, x3 1, y3 1. Okay, these are very easy level of questions. x4 0, y4 is 1. Then find xcm ycm. Directly we can expect, because it is a uniform object, we can expect directly x axis y axis 1 by 2 1 by 2 we can expect, along x axis half, y axis also half, 1 by 2 1 by 2 directly we can expect, because it is a uniform shaped object. Okay, some symmetry distribution is there. xcm is m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. Okay, do it fast. m1 x1 multiply m2 x2 m3 x3 m4 x4 by m1 plus m2 plus m3 plus m4. Check it. What is m1 x1? m into 0 0, m2 x2 m into 1 m, m3 x3 m into 1 m, m4 x4 0 by m1 plus m2 plus m3 plus m4 4m, 2m by 4m. How much it is now? 1 by 2 directly we can expect. Similarly ycm also, do it fast now. So ycm also the same, m into 0 0, m into 0 0, 0 plus 0 plus m plus m, 4m, again 1 by 2. Then what are the coordinates? xcm and ycm is 1 by 2 comma 1 by 2. Okay, directly we can write. Okay, for it maybe it will help for some students at least. Directly we can expect 1 by 2 1 by 2. If you are good in mathematics, I can solve very fast. Okay. Okay. Let me give one more system. So let me write the same. Find center of mass of the system from O as shown in figure. So they given this diagram. So this is also one of the good question today now. Okay, somewhat good question. Okay, so each mass is m. Okay, they given this type of diagram. Find center of mass of the system from O, from that origin. They given that origin. So let us see what they given first. See, these are three identical rods. Keep in mind, these are three identical rods, uniform rods. Three identical rods, each of length L. Three identical rods, each of length L. They join to form a U shape. Three identical rods, each of mass m, length L. Three identical rods, each of mass m, length L, are joined to form a U-shaped object. They are joined to form a U-shaped object. Then we need to find coordinates of center of mass from this origin. Okay, center of mass of this system. See how many rods? Three rods. Each rod mass is how much? Same, m. So m1 is m, m2 is m, m3 also m. m1 is m, m2 also, m3 also m. Identify the coordinates for those three rods. Identify coordinates of those three identical rods. This is possible for only identical rods. If it is unidentical, that is another case. Okay, that we will see. Some integration methods we will see now. Here, identify the coordinates. For this first one, let us take this is m1. m1 is equals to m, and this is the center of mass. It is at the center. So this is at origin along this. From here to here is length L. Tell me the coordinates of the first rod. m1 is m. x1. What is x1? 0. x1 is 0. Origin. Along y-axis x1 is 0. And y1, from here to here is y1. Here to here is y1. So what is y1? y1 is L by 2. Now the coordinates here, coordinates of the first rod 0 and L by 2, because mass is distributed from here to here. So center of mass is at the center. Okay. So L by 2 is the coordinate for first rod along y-axis. 0, L by 2 are the coordinates for the first rod, and this is m2, and see, this is along x-axis, and center of mass is here. This is the center of mass. Now what are the coordinates? Coordinates are, this is along x-axis, so center of mass is at center. So L by 2 along x-axis, y coordinate is 0. So m2 is m, x2 is L by 2, y2 is 0. Now coming to the m3. So this is m3 is m, and at this point identify the coordinates. Identify the coordinates at this point. This point is at a distance of what? L. From this origin. From this origin, this is at a distance of L. Now L, and from here to here height is L by 2. So L comma L by 2. Observe carefully. From here to here is x coordinate is L. Here to here is L by 2. Okay. So m3 is m, x3 is L, y3 is L by 2. So these are the coordinates. Identify carefully, because I given uniform rods. Three identical uniform rods, each of mass m. They joined to form a L shape. Sorry, U shape. Okay. So masses are same. m1 m, m2 m, m3 m. Identify the coordinates. Coordinates of this first rod is, it is along y-axis, so 0 comma L by 2. This is along x-axis, L by 2, because center of mass of this rod will be at this center, at a distance of L by 2. Center of mass is available. So L by 2 comma 0. Here this is at a distance of L from the O. So x coordinate is L, y coordinate is L by 2. Once we know x1, y1, x2, y2, x3, y3, then we can find xcm, ycm in a easy way. Let us get xcm. xcm. Try to solve xcm, ycm. So, xcm m1 x1 0, m2 x2 m into L by 2, m3 x3 m into L by 3m m 3m. Okay. So, this is 2, how much it is now? So, 2 3 m L by 6, 2 3s are 6, 6m. How much it is now? L by 2. I got xcm as L by 2. Let us get ycm. ycm m1 y1 m into L by 2, m2 y2 0 plus m3 y3 m into L by 2 by 3m. ml by 2, ml by 2, nothing but ml. So, ml by 3m. So, how much now? L by 3. So, I got xcm ycm as L by 2 and L by 3. So, I got the coordinates for this system from origin is L by 2 and L by 3. If they ask you to find distance, you can use directly xcm square and ycm square. Up to now coordinates are completed. If they ask you to find distance of center of mass from origin O, okay, distance of center of mass of the system from O, then you can use the root of xcm square plus ycm square. What is xcm square? L by 2 square. Ycm square, nothing but L by 3 square. So, L square by 4 plus L square by 9. Okay, do these simple mathematics. This is L, you can take outside, root of 9 plus 4, 36. This is root 13 L by 6. 9 plus 4, 13, downside 36 is there, 6, 13, root 13 L by 6. That is the distance of center of mass from O. Coordinates are clear, they are asking coordinates. Coordinates are L by 2 and L by 3. Distance, if they ask, root 13 L by 6. Somewhat good question so far now. Somewhat better, because previous questions are very easy level of questions. This is okay, good. See, slowly I am going to increase the level of the questions and concepts, okay, increase your mathematical speed. Let me give one more good question today now. Okay. So, take one more question. Find position of center of mass of 4 particle system as shown. 4 particle system as shown. Okay. So, again they given the diagram. See, they given a parallelogram diagram. See, the given diagram looks like this. Is it okay? Yeah. Yeah, all are identical masses. See, all are identical masses, and the given this one as A and this is B, angle they mentioned theta. They given this diagram, x axis, y axis. Okay, otherwise they will give the data. Okay, we cannot expect the same problem in everywhere. Okay, if you open different books, we will get different problems. Okay, here I am giving idea how to solve the problem. Okay, that's why I written every question in a shortcut way. Yeah, this is A and this is B. Identify first coordinates of all the particles. Coordinates. The given 4 identical masses are placed at the 4 corners of a parallelogram as shown in figure. 4 corners of a parallelogram as shown in figure, and they given this as A and this side is B. Then target is to find position of center of mass of this system. See, if I take this is M1, what are the coordinates here? 0, 0, at origin 0, 0, so there is no one. Here M2, tell me the coordinates. M2 is along x axis, of course it is M, x axis. So from here to here is A, 0. I think you know how to identify the coordinates. Shall I write directly? A comma 0 directly. And see, coming to this M3 is M, tell me the coordinate here. This is, see, this is B and resolve this B into 2 components. Okay, this is not A by 2 and this is not A. From here to here is A and we cannot write this as a by 2, it is not a half. Okay, it is not the midpoint of this. So resolve this B into 2 components. Follow the resolution of vectors concept. So that will play the main role in overall physics. Resolution. Everywhere in free body diagram concepts also, resolution will play the main role in solving problems in physics. So here resolve the B into components. What is B? B, horizontal component of B is very clear. B cos theta, horizontal component from here to here is B cos theta. B cos theta. And this component is very clear, B sin theta. Then what are the x and y coordinate of M3? Here B cos theta and B sin theta. These coordinates are clear. Coming to this M4. Okay, first decide the coordinates. Once you got the coordinates, then substitution is nothing. M1, x1, M2, x2, again the same process. Here this is x. If this is theta, no doubt this is also theta, because it is a parallelogram. If this is B, this is also B, same, theta, theta. And from here to here is A and this nothing but resolve B into 2 components. This is B, B cos theta, and what is this? B sin theta. So this component is again B cos theta and this is B sin theta. Now the coordinates of this one is M4. From origin, okay, from origin, A plus B cos theta is the x coordinate for M4. So A plus B cos theta, x coordinate of M4. Y coordinate remains same, height of that particle from x axis is same. So B sin theta. B sin theta. See, I got 4 particles and I got coordinates of 4 particles. Once we got the coordinates, then we can identify, we can solve XEM, YCM. Solve XEM and YCM for this problem, because next some cube will come, 8 coordinates, 8 particles. Okay, pyramid will come, 5 particles, 5 coordinates. See, What is XEM? XEM M1 X1, M1 X1 0. Of course M1 is M, M2 is M, M3 everything is M. So 0. M1 X1 0, M2 X2, M and A, MA, M3 X3, M3 X3, MB cos theta, M4 X4, M4 X4, M X4 is A plus B cos theta. Let me multiply here, MA plus MB cos theta. I multiplied MA MB cos theta by M1 plus M2 plus M3, 4M. So just you check these calculations, MA 2MA MB cos theta, MB cos theta, 2MB cos theta. So 2MA plus 2MB cos theta by 4M. So M gets cancelled, take 2 outside. So you will get A plus B cos theta by 2. Okay. So M anyhow gets cancelled, 2. So take 2 outside, 2. This is A plus B cos theta by 2. Check it. Find YCM. YCM we can expect directly. So these particles are at the same distance, we can write B sin theta by 2 directly. Height of that system is B sin theta by 2. Okay, try to do YCM. What is YCM? M1 Y1. M1 Y1 is what? 0. M2 Y2 0. M3 Y3 M into B sin theta plus M4 Y4. M4 Y4 again same MB sin theta by 4 times of M. M gets cancelled to be sin theta by 4. So what is YCM? B sin theta by 2. Now what are the coordinates? XCM and YCM is A plus B cos theta by 2, B sin theta by 2. So these are the coordinates for this system. Okay, so this is also somewhat better question today. A plus B cos theta by 2 and B sin theta by 2. Yeah. Say for suppose if this particle shifted here, if this will be shift here, this will come in this side. So you will get a perfect square. If this particle shifted along y axis, what is theta? How much theta value? If this particle is shifted along the y axis, you will get a perfect square. For a perfect square, the angle between the two sides is how much? 90 degrees. So if you substitute theta 90 degrees, and for a perfect square, sides are same. Okay, if it is a perfect square, sides are same. Okay, if it is a rectangle, rectangle means this will shifted. If this will shifted along the y axis, you will get a rectangle. For rectangle also theta how much? Theta 90. If you substitute theta 90, theta 90, then cos 90, this is 0, a by 2, sin 90, 1, b by 2. So what are the coordinates if it is a perfect rectangle? Rectangle, this is not a rectangle, this is a parallelogram. If they given rectangle, so you will get coordinates are a by 2, just substitute theta as a 90, a by 2 and b by 2, a by 2, b by 2. If it is a perfect square, theta 90, ab are same, you will get a by 2, a by 2, or you will get b by 2, b by 2. Okay, so based on given problem you change it. Theta is 90 for a rectangle, theta is 90 for a square. If it is a perfect square, ab values are same. If it is a rectangle, AB are different, A by 2, B by 2. Those are the coordinates. Okay.